This is a demo for the web page interface for articulatory movement estimation in speech production. In this web page, we allow the users to estimate articulatory movements from two modalities, text and speech. When it is being estimated from speech, it is known as acoustic to articulatory inversion, and from text, it is known as phoneme to articulatory estimation. To do the AI task, the user can upload a pre-recorded audio or record it live in the browser. The user can also select a model on which they want to do the inference. We have 5 different models which have been trained on the AI task and has been made available in the inference server. For the PTA task, the user will be entering a text, and this text will be uploaded to the server and converted to phonemes by using a grapheme to phoneme converter. The user can also select a model they want to infer on the PTA task. Now, to give a demo, today we are giving a demo. Now, once you upload it, it will be sent to the server, and it will first compute MFCC features and predict the articulators with the selected model. And in this particular plot, it's plotted across time, and we see that we have 12 different rows. This corresponds to X and Y coordinates of 6 different articulators. And we also have the spectrogram of the audio. Now let us enter the text corresponding to the audio that we have entered. Now, once you enter the text, it will be sent to the server, converted to phonemes, and it will be inferred with the selected model. In this case, we see that there's an additional information that the phoneme boundaries, which is predicted by the fast speech model. Now, one thing we have noticed that the lengths of the two different sequences are different, and this is mainly because of the duration model that is involved in the PTA case. That's why the lengths will be different. Now, one way to use this tool would be to change different models and understand how the articulatory movements are changing. One could use a sentence from Mokatimic and upload it, and also utter the same and understand how exactly are the articulators changing in your case. Now, there is one way to use the tool. Along with that, we also have a metric that is correlation coefficient. Now, what exactly does this signify? Now, consider the AI case, and in training, during the data collection stage, all the audios are collected in a controlled environment, and also the training is done on a limited number of subjects. But on inference, it can be an unseen subject, and it can also be subject to background noise and also microphone characteristics. So due to all these things, we'll consider AI inference as noisy version, whereas these differences won't matter for the case of PTA. So we'll consider the PTA inference as clean. Now, this correlation coefficient will be computed the DTW aligned versions of both these predictions, and this will act as a metric that can tell us the effect of noise into estimating articulatory movements. The web page can be accessed by the link shown in the page. Do give it a try and let us know your feedback. Thank you. That is it for the demo. If you have any questions or suggestions, feel free to write to us or contact me.